My dear students, welcome back to our channel. In this video, I will be explaining the Bachelor of Computer Applications 4th semester subject Advanced Computer Networks as prescribed by Osmania University and other universities of Telangana. We will go through the important questions and answers one by one. Let's begin with a quick revision. Unit 2 first important short question is: write briefly about switching. Switching is the way data is moved from one device to another in a network. Think of it like traffic signals helping cars reach the correct destination. In networks, switching helps data reach the right computer. There are three main types of switching. 1. Circuit switching, like a phone call. A fixed path is made before data is sent. Example, old telephone system. 2. Packet switching, data is broken into small packets. Each packet finds its own way. Example, internet, emails. 3. Message switching, the whole message is sent to one switch, stored, then sent to the next. Example, like sending a parcel via post office. Easy trick to remember. Circuit, call, packet, internet, message, post office. Switching makes data transfer smooth, fast, and efficient in big networks like the internet. Next important short question is: 2. Datagram networks. A datagram network is a type of packet-switched network where each packet, called a datagram, travels independently. There is no fixed path. Each packet can take a different route to reach the destination. Think of it like sending many postcards to a friend. Each postcard, packet, may take a different post office route, but all reach the same friend. In a datagram network, no need to set up a path before sending. Fast and flexible. Packets can arrive out of order or get lost. Example: the internet uses datagram networks. When you send a WhatsApp message, it's broken into packets that travel separately and are joined again at the other end. Easy trick to remember. Datagram is equal to data plus telegram, like sending multiple telegrams without a fixed route. Datagram networks are simple, efficient, and work great for the internet. Next, Unit 2. Long questions. First important long question is: 1. Explain about circuit-switched networks. Answer: a circuit-switched network is a type of communication system where a dedicated path, or circuit, is created between the sender and receiver before data is transferred. Once the path is made, all data follows that same path until the communication ends. Easy example. Think of it like making a phone call on a landline. When you dial someone, a dedicated line is created between your phone and your friend's phone. You can both talk without interruption because the line is only for you two. How it works? 3 steps. 1. Connection setup. A fixed path is established between sender and receiver. 2. Data transfer. Data moves along that path. 3. Connection teardown. The path is released when communication ends. Advantages: reliable, since the path is fixed, data arrives in order. No delay during communication, good for real-time voice or video calls. Disadvantages: wastes bandwidth. If no one is talking, the path is still reserved. Takes time to set up the connection before sending data. Real-life examples: old telephone networks, BSNL landlines. Traditional voice calls over PSTN, public switched telephone network. Easy trick to remember. Circuit is equal to call. When you call someone, a circuit, path, is made just for that call. No one else can use that path. Summary. Circuit-switched networks create a dedicated path for the full duration of communication. Best for continuous data like voice and video. Not good for occasional or bursty data like emails or browsing, as it wastes resources. This method is less used today because modern networks, like the internet, prefer packet switching, which is faster and more efficient. But circuit switching is still important for understanding how traditional networks work. Next important long question is: to explain about virtual circuit networks. Answer. A virtual circuit network is a type of network where a logical path is created between the sender and receiver before data is sent, just like a circuit-switched network. But here, the path is virtual, not physical. It combines the best features of both circuit switching and packet switching. Easy example. Imagine you are sending many parcels to a friend. Instead of sending each parcel separately with different addresses, like in a datagram network, you write a code number, VC number, on all parcels. The post office knows the path for that code and sends all parcels the same way. So, even though the network is shared, your parcels follow the same path. How it works? 3 steps. 1. Setup phase. A virtual path is created with a special ID called Virtual Circuit ID. 2. Data transfer. All packets follow this virtual path in the correct order. 3. Teardown phase. The path is deleted after communication ends. Advantages. Reliable delivery. All packets follow the same path and arrive in order. Efficient use of network. No fixed circuit, so resources are shared. Disadvantages. Setup delay. Takes some time to set up the virtual path. If one link fails, the whole virtual circuit breaks. Real-life example. Frame relay. ATM, asynchronous transfer mode. MPLS, used by ISPs for traffic management. Easy trick to remember. Virtual circuit is equal to packet plus path. Packets move like in packet switching, but all follow one set path like circuit switching. Summary. Virtual circuit networks create a temporary logical path before sending data. Packets follow the same route, making delivery fast and ordered. It's like a shortcut in a crowded city. Everyone who knows the shortcut follows the same way. Next important long question is: 3. Explain about message-switched networks. Answer. A message-switched network is a type of network where the entire message is sent from one device to another, one hop at a time. Each device in the path stores the whole message, checks it, and then forwards it to the next device. This is called store and forward. Easy example. Think of it like sending a letter through a post office. You write a long letter and drop it at your local post office. The post office stores it, reads the address, and sends it to the next post office, and so on until it reaches your friend. Each post office stores the full letter, then forwards it. How it works? 1. The sender sends the full message to the first switch, network device. 2. The switch stores the full message in memory. 3. Then it forwards the message to the next switch. 4. This continues until it reaches the receiver. Advantages. No need to set up a path before sending. Useful for long messages or files. Each message can take the best path available. Disadvantages. Delay due to store and forward at every switch. Needs more memory at each switch to store full messages. Not suitable for real-time data like voice or video. Real-life example. Telegraph systems, old government message systems. Early email systems. Used in military or postal-style communication systems. Easy trick to remember. Message switching is equal to like a post office. Each message is stored and then forwarded step by step, just like a letter. Summary. Message switched networks send the whole message one hop at a time. Uses store and forward technique. Best for sending large messages when time is not critical. Not good for live communication like voice or video calls. Next important long question is 4. Describe briefly about asynchronous transfer mode. Answer. Asynchronous transfer mode, ATM, is a high-speed networking technology that sends data in small fixed-size packets called cells. Each ATM cell is 53 bytes, 5 bytes for the header and 48 bytes for data. Unlike other networks where packet sizes can vary, ATM always uses fixed-size cells, which makes it fast and predictable. Easy example. Imagine you are sending water through pipes in small bottles, cells, each exactly the same size. Because all bottles are equal, it's easier to move them quickly, store them, and manage traffic. That's how ATM works. How ATM works. 1. Data, voice, video, text, is broken into fixed-size cells. 2. Each cell is given a label for routing. 3. Cells travel through virtual circuits in the network. 4. At the destination, cells are reassembled into the original data. Advantages. High speed works well for broadband networks. Supports all types of data, voice, video, images, and text. Fixed size cells, easy to manage and switch quickly. Low delay, good for real-time services. Disadvantages. Expensive, setup and maintenance cost is high. Complex, more difficult to implement than Ethernet. Less used today, replaced by newer, cheaper technologies. Real-life example. Used in banks, telecom networks, and ISPs for fast and reliable data transfer. Previously used in BSNL broadband core networks. Easy trick to remember. ATM is equal to always tiny messages. All data is sent in tiny, equal-sized cells, fast and organized. Summary. ATM sends data in fixed 53-byte cells using virtual circuits. Good for high-speed networks handling voice, video, and data. Fast, reliable, but costly, now replaced by newer technologies. Next important long question is 5. Broadband Integrated Services Digital Network. Broadband Integrated Services Digital Network, BISDN, is a high-speed communication system that was designed to send different types of data like voice, video, text, and images all through one single network. It was developed to improve over the older ISDN, Integrated Services Digital Network, which worked at lower speeds. BISDN supports broadband services, meaning it can handle large amounts of data quickly. Easy example. Imagine you want to watch a movie online, make a video call, and download a file all at the same time. BISDN was designed to handle such multiple services smoothly on a single connection. Key features. Uses asynchronous transfer mode, ATM, to send data in fixed-size cells. Supports high data rates, above 2 megabits per second. Designed to carry multimedia data, voice, video, images, etc. Based on fiber optic technology for fast and reliable transfer. Advantages. 1. Network for all services, no need for separate lines. High speed, suitable for broadband internet and video conferencing. Supports real-time communication like live TV or calls. Disadvantages: very expensive, hard to install in rural or low-income areas. Complex technology, difficult to maintain. Replaced by newer systems like DSL, fiber internet, and 4G per 5G. Real-life use. Though not widely used today, BISDN was a foundation for modern broadband and was used in some high-end telecom and government networks. Easy trick to remember. BISDN is equal to Big ISDN. It's like an upgraded, faster version of ISDN that can carry more data for more services. Summary: BISDN is a high-speed digital network for sending voice, video, and data together. Based on ATM and fiber optics. Paved the way for today's broadband and multimedia networks. Next important long question is: 6. Explain about adaptation layer. Answer: the adaptation layer is a part of the ATM, asynchronous transfer mode protocol. Its job is to take different types of data like voice, video, or files and prepare them to be sent in small, fixed-size ATM cells. Think of it like a packing department in a factory. Different products, data types, come in different shapes and sizes, but the delivery truck, ATM network, only accepts small, same-sized boxes, cells. So, the adaptation layer packs each product perfectly into those boxes. Easy example. Imagine you want to send a video and a text file over the ATM network. The adaptation layer will first break the data into small pieces, then add headers and control info, and finally fit them into ATM cells, 53 bytes each. Functions of adaptation layer. 1. Segmentation, breaks large data into small parts. 2. Reassembly, combines small parts back into the original data at the receiver. 3. Error control, checks for mistakes during transmission. 4. Timing and flow control, keeps data flowing smoothly. ATM layers overview. ATM has 3 layers. 1. Physical layer sends raw bits. 2. ATM layer routes the cells. 3. Adaptation layer, AAL, prepares and packs the data. Types of AAL, adaptation layer. AAL1 for constant data, e.g. voice, video calls. AAL2 for variable bitrate voice. AAL5 for data like files or emails, most used. Advantages. Supports different types of services, voice, video, data. Ensures proper delivery of data. Makes ATM flexible and powerful. Easy trick to remember. Adaptation layer is equal to smart packer. It prepares all types of data so they fit perfectly in ATM cells. Summary. Adaptation layer is part of ATM that prepares data for sending. It packs and unpacks data into ATM cells. Helps ATM work with different services like voice, video, and files.